Hi there, welcome to 11.2 Hypothesis Tests for the Difference Between Two Proportions. And we're going to dive right in. So, page 542, number 10. In a random sample of 340 cars driven at low altitudes, 46 of them exceeded a standard of 10 grams of particulate pollution per gallon of fuel consumed. In an independent random sample of 85 cars driven at high altitudes, 21 of them exceeded the standard. Can you conclude that the proportion of high altitude vehicles exceeding the standard is greater than the proportion of low altitude vehicles exceeding the standard? So as I read it again, I see there's one sample of 340 cars and 46 of them exceeded this standard. So there's one sample. So I'll put that maybe down below. Sample 1, which is the low altitude. We have a sample size of 340, and out of them, an X value of 46. And then we have a second sample. A second sample of 85 cars at high altitudes. 21 of them exceeded that same standard. So sample number 2, which is the high altitude, we've got a second sample size and a second number out of that total. And I see as I read the problem, I've got that word proportion right there in the problem. So I know that this is proportions, and I see that now careful, the language here we've got is the proportion of high altitude greater than the proportion of low altitude. So that language is a little bit tricky. So I'm going to write that down. So we're seeing does the high altitude exceed, is it greater than the low altitude, which is a little bit backwards from what we've got. I'm calling my second sample the high altitude and the first sample. So if I'd flip this around, we're saying that P1 is in fact less than P2. So that's what we'll use in our hypotheses. So it is important to read these problems a couple of times and read them super carefully. And then once you sort that out, then the hypothesis test becomes fairly straightforward. So now we'll set up our hypothesis test. So first step, hypotheses. The null hypothesis would be that there's no difference, that the low proportion is the same as the high proportion. And our alternative would be that the high proportion is greater than low. You could write it in that order. I don't mind this first version I wrote down, but just to be consistent and so that we match the calculator, I'll write P1 less than P2. The low altitude is less than the high altitude pollution. All right, step 2, we identify this as a two proportion problem. No longer two means, two proportions. Therefore, we do use the normal distribution, also known as the z-distribution, and it's going to be a left-tailed test because we've got that less than ultimately. So it's super important to keep track of that. Okay, and if we set up our distribution, we're back to normal. So we've got alpha. Oh, I didn't write it down. Our book gives that, in one of the parts. So the book gives us use alpha equals 0.01. So I will use that down here in my normal distribution. Alpha is equal to 0.01 in that left tail. So inverse norm on that 0.01, our usual 0 and 1, gives me a critical value of negative 2.33. So that's our critical value. Again, always, as best you can, label all your numbers because there's so many of them floating around. All right, my step 3, I'm going to go to 2 prop z test. Hopefully pretty intuitive, two proportions, and we're doing a test. Plug in all your information. The tricky thing, make sure you get those numbers in the right spots. Where N1 is not the first number you're asked for. So you want to read the labels really, really carefully. And again, make sure then you use the correct less than notation for P1 being less than P2. And I got a test statistic of z equals negative 2.53. and a p-value, which again, please label all these numbers, label, 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 0.0057. So if I want to get my extra credit, I'm going to show both comparisons. Bring back our drawing, or if you haven't done it yet, this is the place to do it. Reject H0 in that left tail past negative 2.33. And our test statistic, yep, test statistic is negative 2.53. Again, labeling as best you can, critical value versus as test statistic. And then the second way, comparing the p-value to the significance level, 0.0057 is indeed less than 0.01. So both of those methods agree. Our first part of our conclusion is that we are going to reject the null, and then we write some sort of statement about the conclusion. Here's what I wrote. At the 0.01 significance level, we can conclude that more vehicles pollute at high altitudes than at low altitudes. Right? The proportion of all these vehicles are polluting, some portion of the cars are polluting, and there's more of them at the high altitudes than at the lower altitudes. All right, so hopefully that felt somewhat familiar because it's the same structure and just a new piece on the calculator. There really aren't any surprises in this section. So the only other problem I'm going to do is page 543, number 20, more practice reading from a display. So this is this software program called Minitab. And we are first asked, is this a left-tailed test, or right-tailed test, or a two-tailed test? So looking at the output, we've got a test and a confidence interval in one output. That's pretty nice for two proportions. We've got the two variables, two x values and two n values. That's like our x1 and x2, n1 and n2 up above. And then here are the sample proportions. So this would be p1 hat and p2 hat using our notation. And then we're looking at the difference, p1 minus p2. And then there's the point estimate right there, the second number down, and then we've got the confidence interval. We don't need that for this problem. And then a test of difference versus not equal to 0. So right here, this is our part A information. Test of there being a difference, so that you subtract and get 0, versus simply not 0. It would have said greater than or less than if it was a one-tailed test. But this is a two-tailed test. So the fact that it said not equal to 0 makes this two-tailed. And then what's the p-value? That's pretty clearly labeled on there. The p-value is 0.008. And then can H0, the null, be rejected at the 0.05 level? Yes, we don't have to write out the whole test on this one. So if I just simply compare that p-value to alpha, 0.008 compared to 0.05, we've got that less than symbol in between there. So yes, reject the null. And I think that's enough explanation showing specifically what we are comparing to make our conclusion. And that wraps up 11.2.